Hello, Ms. Sale. How have you been?
I've been well. How was your weekend?
Excellent. Now it's Tuesday.
Getting a little warm.
Yes, warm on Tuesday. 2 for Tuesday.
No Taco Tuesday.
That too.
That too. Okay.
2 tacos, 2 Tuesdays, you and me. 2, 2, 2.
Today,
Wow. Fancy.
we're going to go over the lab that we did on Friday with the tennis ball tossing. Now, some people told me that they had trouble walking and tossing the tennis ball, which was totally not what the lab was about. Some people, Cameron,
Stop
said
chewing
that,
gum.
yeah,
While you
chew
walk,
gum.
walk.
No,
Put
some
your
people.
phones down. Sorry, excuse me.
You done?
I'm excited. It's been a long weekend.
Yeah, okay. Some people said they couldn't catch the ball, which also is not what the lab was about. So the lab was about changing position, and the lab was about your perspective and using your own self as a reference point, or using someone else walking by in front of you. And you are still a reference point, but what's happening to the movement of the ball. So on Friday, when we did this and you watched me walk by with the ball, I noticed that your head went like this as you walked by,
Yes.
right? So as I toss the ball, my head goes up and down to watch the ball. But my head does not do what your head did when it went like this. So when the perspective is coming, when it's my perspective and the ball's in front of me, my head just goes up and down. But when the ball goes by in front of you and it's getting tossed, you are not only moving up and down with the ball, you are also moving side to side as the ball moves. So your first picture should have shown the ball just going up and down, as if you were throwing it like this and your head is just going up and down. So ball with arrows going up and then back down again. So up and then down. But then when someone else is walking by in front of you, your new perspective is that the ball is traveling like in a loop, in a wave, kind of. Yeah?
Yes.
So it's not only is it going up and down, but it's also going from one side to the other. You didn't change, but your perspective on what the ball's movement was doing changed. So your first conclusion question, compare your two sketches. How is the change in position of the ball you tossed different from the change in position of the ball that your partner tossed? Well, I just explained it. When you toss it, it just seems to go up and down. When your partner tosses it, it not only goes up and down, but it moves
Side to side.
Side to side. Very good. Number 2, explain how your reference point affected what you observed. Well, your reference point, if you are the reference point, you stay the same, but the action or the movement of the ball seemed to change. Even though the ball wasn't really changing, it's the same when I'm tossing it and walking and you're watching it, the ball's still doing the same thing. But the reference point is what seems to make the ball change the motion. Number 3, how would the change in position of the ball appear to a person standing 6 meters directly in front of you? So if you are my other person, and you're 6 meters away, and I'm tossing the ball and walking right toward you, what does it look like the ball's doing? Again, the ball is just going up and down, because if we're head on like this, I'm directly behind it, it just is going straight up and down. You're directly in front of it, it's just going straight up and down. The ball might seem to get bigger because it's getting closer to you, but there's no side to side movement on that one. So that was it for that lab.
Sounds good.
Just to give you some perspective on how things can look completely different. Even though the ball's movement didn't change, it looks completely different from me as it does to you, right?
Right.
Okay, next thing, our focus question. So the focus question that we started with, that you already wrote in your science notebook, is, what is motion? And here's motion. Motion is the change in position over time. Motion can be up, west, over, through, left, around, or any other movement. Motion is often determined by using a non-moving reference point. And I'm gonna hold this up so you can see it and you can write this in your science notebook. And I have to make one correction. I forgot a comma. So I gotta put a comma in there. Okay, so I'll hold this up so you can see it. Make sure you can see that. And then you can pause it. And you can write that in your science notebook. Okay, there you go. Okay, so now we have do we have a new focus question? Okay, the new focus question. No, not yet, sorry. You gotta take a quiz on this. Okay, you have to take the quiz. You have a quiz on Review Packet Quiz 1.1. It's on my website under Worksheets. And take that Review Packet quiz, take a picture of it, email it to me. And then I would like you to read, do, and take notes on the Chapter 1 packet, Section 1.2. It's pages 5 through 9. And we have some other stuff to go along with that we'll do later this week. And that's it for your Tuesday.
Wow, that was good.
Yeah. It's getting close, Ross.
Graduation's coming.
We're coming to the end.
To the end.
Yeah. Not the way I thought it was going to happen, but hopefully I'll get to see everybody again next
year.
Next week. Well, next week.
They'll come back and visit you.
Yeah, they better come back and visit us, huh?
Yes.
Yes. Yes, they better come back and visit us.
The week's not over.
I know. Okay.
That's it. I'm out.
Are you out?
That's all I got, man.
That's all you got. Okay. I love you. See you tomorrow.
Tomorrow. Bye-bye.